Okay, so in this video we're going to be having a look at some of the key topics that didn't appear on paper 1. Now, similar to before, we are going to go through the first half of the video, and that part of the video is applicable to foundation and higher as it goes up to the style of grade 5 topics. At a point in the video I do stop and say from now on it's higher only, and we move on to those grade 6 and above topics. Now, just like before, a lot of the topics that I've selected in this video are the topics that don't appear in my practice paper. Those of you that follow the channel know that there will be a practice paper that goes live the day before the exam, so you can finish off your revision covering all of those key topics that haven't yet appeared in paper 1. So just like before, do make sure that you check the most recent videos on my channel, as that includes all of the topics that you need to make sure that you've revised leading up to that paper 2 exam. But otherwise, you have my practice papers that will go live the night before the exam, or if you're a live member, you'll know that they're already in the members area and you've probably already got access to them. But otherwise, we're going to get started with this video because there is a lot of topics to get through, but I'll see you for my next video looking at those practice papers. Okay, so for the lowest common multiple, you can either write these numbers as ordinary numbers, or you can find the lowest common multiple from prime factor form. So what we can do is we can write out this list in long form. So A is 2 times 2. There's quite a few 3's here. We've got 4 3's and a 7 at the end. The B number that we have here, we've got 2 3's, which I'm going to align over here next to the 3's, and then we've got 2 7's. Now we should hopefully remember from finding the highest common factor that to find the highest common factor you have a look at what's in both and then we multiply those together. To find the lowest common multiple, all we do is after we've multiplied those numbers together that are in both, we then take all the remaining numbers and add that onto the end of our multiplication. So times 2 times 2 times 3 times 3 times 7, and then we just need to type that into our calculator. So 3 times 3 times 7 times 2 times 2 times 3 times 3 times 7, and that gives me, and this is a very large number for this one, but we get a lowest common multiple of 15,876. Now you can also put these numbers into a Venn diagram if you prefer that visually. The numbers that are in both go into the middle, so we would have had a 3 and a 7. And then the remaining numbers that were in A, we could put on the left. The remaining numbers in B, we could put on the right. That would only be a 7 that goes in there. And we'd have 2, 2, 3, and 3 here. And then you just multiply all those numbers together for the lowest common multiple. Completely up to you, but two different ways that you can look at it visually. Of course, you could write this as a list, but for this type of number, where we're going into the thousands, it's probably better that we apply our products of prime factor rule to this one. Okay, so for a frequency polygon, there are a few things you could be asked about the table. This one here is asking us to find the class interval that contains the median. So for 80 plants, we're going to have a look at where that halfway point is. There are two ways to look at this, but typically we can just divide that by 2 and find where the 40th plant is. Now if we count down cumulatively. So 7 add 13 gets us a total of 20. Add the 14 gets us to 34. And then we go past 40 on this next one, we get 46. So as we've gone past 40, our median is in this category just here. So we just write down that category between 40 and 50. For part B, it does ask us to draw the frequency polygon. To do that, we plot using midpoints. So for each one here, we want to identify the midpoint. They tend to be in nice even intervals here. So you can see each time it's just between the two tens. So nice and easy for you to find those medians. Just make sure you check on your graph very carefully where those median points are. So just in between all of these, you can mark them on before you start plotting them if you want. And then we just need to plot them on those frequencies. Check the scale very carefully. This one here, 2 squares is equal to 1. So I just need to be very, very careful when I plot these. And there we go, nice little cross on each one, marking them really clearly, and then we're just going to join them up with nice straight lines, and that will be completed. There we go, I can just about get these all in the right place, and then we have 16 up here, and the last one is 18, which is just below the 20, so that's there, and then we join that up, dot to dot, nice straight lines, no curved lines here at all, no joining them up from the first to the last point. We are just going dot to dot from left to right, making sure that we join all those points up, and there we go, there's our frequency polygon. Obviously just make sure that your lines perfectly join up and connect those points there. I've actually just slightly missed this point as I'm doing it on the screen, but just make sure that when you're doing it, it's absolutely perfect when you're joining those together. And there we go, there is your frequency polygon. Now, fractions are typically a non-calculator style of question. However, we can have these types of questions where it says show that. So the show that type of question does require you to actually do the working out, and therefore you can't just type it into a calculator. So just be really, really careful with that language. Of course, that can apply to any type of fraction. For this one here, we have an addition in question 1. When adding fractions, we need to make a common denominator, and they need to be in as or written as improper fractions. So the first one, 1 times 5 add the 3 is 8 over 5. The next one, 2 times 4 add 1 is 9 over 4. It's exactly the same for addition or subtraction. We just need to make a common denominator, so showing very clearly how we're going to do that. So I'm going to times the left by 4, right by 5. That gives me 32 over 20, and it gives me 45 over 20. And we add that together, 50, 60, 77 over 20. And then here is the part where you have to be very careful. Now, typically, of course, if you were just going to do this on a calculator, you could literally just type that in and it would now give you the simplified form. And 77 over 20 is in its simplest form, but we're going to have to write it as a mixed number. So we're going to have to show very clearly how we've done that. So 20 fits into 77, 20, 40, 60 fits in 3 times, and there's a remainder of 17. Now, there's not really an easy way to do that on your calculator. If you type in 77 divided by 20, you'll get 3.85, which does at least tell you that there is a whole number 3, but you still need to work out that remainder. I guess you could then do 3 times 20 and see what was left over, but hopefully sort of calculations like that you should be fine with anyway. But there we go, 3 and 17 over 20 is our final answer. For the division question here, again, we take the same approach. We need to make sure that they are written as improper fractions. So 2 times 3 is 6, add the 2 is 8 over 3, and we're dividing by 6. Now, as we are doing a division, I would write that as 6 over 1, and therefore we can now do our reciprocal, or multiply by the reciprocal, and we can show that we are going to do times 1 over 6. Now again, if we type that into our calculator, it will get us straight to 4 over 9, but we're trying to show that it equals 4 over 9. So let's just apply our normal rules, times the top, 8, times the bottom, 18, and it allows us to show that we're now going to divide by 2, which is going to get us to that 4 over 9. So it's just watching out for this show that, making sure that we actually do show the steps that we're being asked to show. And there we go, there is some fractions. Now, a reverse mean question can typically be easily identified because a question will tell you that the actual mean of something. So here it says 4 red bricks have a mean of 5 kilograms. Now all you have to do is reverse what you would normally do with a mean. So normally, to work out the mean, you get the total, divide by how many there are, and you get your mean. Here, we're given the mean, but we don't know the total. So what we can do is take that mean of 5 and multiply it by how many there are, which in this case is 4. And that gives us a total of 20. Now this is about weight, so that would be 20 kilograms. And that's the total weight of the 4 red bricks. We can then do the same with each other line or thing that we are given. So here we are told that there's a weight of 9 for 5 blue bricks. So 9 times 5 is 45 kilograms. And we have 1 green brick with a weight of 6. We don't really need to write a multiplication down for that, but 6 times 1 will give us a weight of 6 kilograms. Now, it says Donna says the mean weight of the 10 bricks is less than 7. Is Donna correct? Well, we can see if Donna's correct because if we add all of these together, so 20 plus 45 plus 6, that gives us a total of 71 kilograms. We already know that there's 10 bricks, but it does say it in the question here. If not, we can just add up the 4, the 5 and the 1. So to work out the mean, 71 divided by 10, which gives us a mean of 7.1 kilograms. Now this question has asked us, is Donna correct? So we do have to answer the question. Just giving the working out that shows she's not correct is not quite enough here. We do have to say, no, Donna is not correct. So just watch out for these questions where it does ask you to give a written answer. Just make sure that you do actually give that. And there we go. No, Donna is not correct. And we've shown how we've got our answer with nice clear working. Now for a scatter graph, the big thing straight away, as soon as you see a scatter graph, draw on a line of best fit. Now a line of best fit on a scatter graph is just a nice straight line that goes in the general direction of the points. Now typically that line will have some points above and some points below. So I've just freehanded a line there. Obviously you would do that with a ruler and a pencil, and you can see that there's a few points below and a few points above, and it goes in that general direction. So there we go. I'm happy with that line of best fit, although it could be slightly different for different people, and that's fine as well. Now this one says Jamie got a mark of 34 in the science test. Use the scatter graph to work out an estimate for his mark in the maths test. So we want to find 34 on the scatter graph, again being careful of the scale in this question, and then we're going to trace up to our line of best fit, and this bit of working out is really important because we are reading from our own line, which does allow us to have a bit of a variation of our answers, and that for me comes out as 39. So my answer for this would be 39. I've showed it nice and clearly using my line of best fit. You can be asked a few things about a scatter graph. So we can be asked about the correlation. This one has a positive correlation as it's sloping up. We can be asked about the relationship. This particular scatter graph shows that the increase in science marks, or as students got higher science marks, they also got higher maths marks. So when you're describing a relationship, you're actually looking at the context of the question and writing about what it shows. You can also be asked about things like outliers and why they're there. So something like this, you could have an outlier that's nowhere near the points, and maybe you would say, well, this is just somebody who does better at maths than in science. And sometimes you can be asked to give reasons for them like that. But there we go, there is a scatter graph and all the little bits and bobs that you can be asked about them too. Now we've already looked at a median from a table, but this one's looking at estimating the mean from a table. Watch out for that word estimate. In this case, it's not asking us to round anything. It's an estimate because we only have categories here. So when finding the mean, which is just timesing across, getting the total, and then dividing by how many there are, in this case there are 20 people, well, we have to use the midpoint, and that's why it's an estimate. So the midpoint for that one would be 200. If you're not sure on the midpoint, you can add the two numbers together and divide it by 2, nice and quick on your calculator. We have 300 as the midpoint here, 400, 500 and 600. So nice sort of rounded numbers there, nice and easy for us to now times across. 1 times 200, 11 times 300, and again, you can just use your calculator for this. So as I'm sort of writing these numbers down relatively quickly, of course, you would just be typing them into your calculator. 400 times 5 is 2,000. 0 times 500 is 0. Watch out for those zeros in these. And then 1,800. We now want to add all of those together. Again, when you do type these into the calculator, just be super careful. It's so easy to type a number in incorrectly, but that one gives us 7,300. Now this final step, don't rush it because we do want to make sure that our answer makes sense. So 7,300 divided by 20, which will give us our mean, and that for me comes out as 365. So my mean, and I'm confident that mine's correct there, is 365, and I'm confident that it's correct because 365 is in this category here, which is somewhere close to the middle. It normally is when looking for the mean, unless you've got a huge amount in the first or the last category. And the answer makes sense. It's not outside of the range 150 to 650. So there we go, £365 is the estimate for the mean from this table. When looking at sampling, we are essentially going to be working out a fraction or a percentage of an amount, depending on how we look at it. But this one here says that there are 100 people asked which type of chocolate they like best. So this is out of 100. It says the shop is going to buy 6,000 chocolates next week. Work out how many dark chocolates they should buy. Well, if we look at the dark chocolates just here, then there's 40 out of 100 people in this sample wanted dark chocolate. Now that equates to 40%. So what I could do is I could take my 6,000 and I can either work out 40% if you prefer to do percentages, or I can work out the fraction of the amount. Now the fraction might not always be a nice percentage, as this was out of 100 is a nice percentage, but I can work it out as a fraction regardless, so up to you. I can either do 6,000 and then divide that by 100 and times it by 40. And I can just do that on the calculator. So divide by 100 times 40, and that gives me 2,400. That was me doing a fraction of an amount. Or I could do 6,000 and I could just times it by 0.4 or 0.40, depending on how you want to write it. And that'd be working it out as a percentage. And there we go, my answer comes out as 2,400. And that is looking at some sampling. Now, of course, sometimes we make assumptions when doing this sample, and we are making an assumption here. We are assuming that the sample represents the rest of the people that are going to come and buy these chocolates. But there we go, there is some sampling. Now, with angles in parallel lines, of course, you just need to be very careful here. Make sure that you know all of your different angle rules. You have your alternate angles that make that almost Z shape. You've got corresponding angles that make that F shape. You've also got co-interior angles, which are when they are inside. So that 125 there is co-interior with this one, and they add up to 180 degrees. Now, typically these questions are only asking you to find some particular angles, but if you look at the diagram, try and have a think about, is there any other angles that you can find straight away anyway, which might just open up the question. So before we even look, I can see that that is a co-interior angle, and I might not need it, so I don't want to waste any time. But if I can see them nice and quickly, I can always fill in some of these angles. I can see that's 2 angles on a straight line there, and then we also have this one here, 2 angles on a straight line. Then there's others that I can go from there, but this does say show that ACD is an isosceles triangle. Now this is ACD just here, and an isosceles triangle has 2 angles that are the same. So I want to prove that 2 angles are the same. Well, I've already got that 55. These are vertically opposite angles, so that would be 55 there as well. And then I want to find this final angle, 180, take away the 70, plus the 55, the 2 angles that we've just worked out. Again, I'm just going to type that in on my calculator. 70 plus 55, take it away from 180, and that equals 55 degrees. So this is an isosceles triangle. Again, it did say show reasons for each stage of your working. So this one here, we had co-interior angles. Sum or add to 180 degrees. We had vertically opposite angles are equal. We had actually quite a lot of rules here. Vertically opposite angles are equal. We had angles on a straight line equal 180. And then to finish it off, we had angles in a triangle. I'm going to write sum to 180 again, but we had angles in a triangle adding up to 180 as well. Now you might want to write for something like this where it says show that it's an isosceles. You'd probably want to write some sort of explanation here along the lines of 2 angles are the same, and in an isosceles 2 angles are the same. Of course it's the base angles, but this one here is rotated on its side slightly. So there we go, 2 angles are the same, therefore it is an isosceles. Now a Venn diagram, of course, gives you some numbers that you're allowed to put into the Venn diagram. This one here, we are allowed to use the numbers from 1 to 10. It then tells us out of that, the even numbers, 2, 4, 6, 8 and 10 are going to go into A, and the factors of 10, 1, 2, 5 and 10 are going to go into B. Any numbers that are in both, we're going to put into the intersection. So there's a 2 that goes into both and a 10 that goes into both. So 2 and 10, and we'll cross those off our list. For A, we have 4, 6 and 8, which are still going in A, cross them off the list. and we have 1 and 5 which go into B, and again we'll cross off the 1 and the 5, and any numbers we've not crossed off, so 3, 7 and 9, will go into the outside. Quickly count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we know that we are only allowed the numbers 1 to 10. So 10 numbers, no repeats, happy with our Venn diagram. We do have some different aspects of set theory that we can be asked about. This particular one is asking about A and then the intersection B. Now the intersection symbol is asking us about these numbers in the middle here in the crossover part. That's the intersection. So the probability that it's in the intersection, well, there's 2 numbers there and there's 10 numbers in total. I don't need to simplify that, you can do, but if you're going to simplify a probability, make sure you just type it in on your calculator, it'll simplify it for you, or just leave it. You don't gain any marks for simplifying it. You could also be asked about the union. The union is your little U symbol, and the union represents all of the numbers in the circles all together. You can also be given things like A dash, which means not in A. Now the numbers not in A, you've got the ones just in B, and you've got the one just on the outside here, but you wouldn't be allowed any numbers there that are in the A circle. So lots of different bits that you can be asked about with the Venn diagram. This one was looking at the intersection, and there is your Venn diagram. So when you have a density, mass and volume question, regardless of what type of question it is, and there are lots of different types of questions, you need to make sure you know your formula. Density is equal to mass divided by volume. Now if you want, you can write that into a formula triangle so that you can use any rearrangement of it nice and quickly, but density is equal to mass over volume. This particular one is looking at a mixture question where a few liquids are getting mixed together, and what I tend to do is always write this into a two-way table just to organise all my information, find out what densities, what masses and what volumes I have. We have a liquid A, liquid B and liquid C. So this liquid A has a density of 1.8, liquid B has a density of 1.2. There is 80 centimetre cubed, which is a volume of liquid A, getting mixed with 40 centimetre cubed of liquid B. And it says that that makes 120 centimetre cubed of liquid C. So you can see here for A and B we are missing the masses, and it wants us to work out the density of liquid C. Now density is the only thing in this table which cannot be added together. Volumes can, masses can, but the density is going to be somewhere in between 1.8 and 1.2. So when we find this, to get the mass, if I cover up the mass on my formula triangle, it's density times volume. So 80 times 1.8. And when you do this, even though we're doing it on the calculator, we want to make sure we write this working out down. How did we get this 144? We did 80 times 1.8. We're going to also do 40 multiplied by 1.2, and that gives us 48 as the mass of B. Again, I would want to show that working out to the side. And we're going to add together the masses, which gives me a total mass of 192. I can now finish this off using my density is equal to mass over volume formula, and that would be mass of 192 divided by 120, and we should get an answer that's somewhere in between 1.2 and 1.8, and as it turns out, this comes out as a nice rounded 1.6. So my density there is 1.6. The units, which if they're not given to you, are given to you up in the question, so that's grams per centimetre cubed. However, do look, that's normally given to you on the dotted line when you're asked to work out a density. But there you go, there is a density mixture. So with a simultaneous equation, you can either look at the coefficients of x or the coefficients of y. I always look at the coefficients of y, and I'm going to make those the same. So 2 and 3, the lowest common multiple is 6. So if I times the top equation by 3 and the bottom equation by 2, those coefficients will be the same. Remember, everything's getting times by 3, so it becomes 15x plus 6y is equal to 33. And on the bottom there, we have 8x plus 6y is equal to 12. Now when the symbols in the question, or the two equations are the same, we subtract these equations. So the same symbols we subtract, otherwise we add them together. So I'm going to look which one has the bigger numbers in. So 15x, I'll do 15 take away 8, which gives me 7x. And I'll do 33 take away 12, which gives me 21. That means now look, when I divide by 7, I get a nice number here. We get x is equal to 3. Of course, remembering you can get decimals, you can get negatives, you can get negative decimals in this scenario here. If you do, that's fine because we're going to be using a calculator for this. So if you do get that, don't panic, they can come out as decimals. Now I've got x is 3, I need to substitute it back into one of the equations. It doesn't matter which one. If there is a negative in the equation, I tend to try and avoid that one. But if we substitute it into the first one, we get 15 plus 2y is equal to 11. I can now subtract 15, which gives me 2y is equal to, and 11 take away 15 does give us a negative. We get negative 4, and when we divide that by 2, we get y is equal to negative 2. And there we go, there is our simultaneous equation. I want to write down both the answers, so x equals 3 and y is equal to negative 2. And there we go, there is a simultaneous equation. Now with speed, distance, time, similar to when we were looking at density, we need to make sure that we write down the formula. Speed is equal to distance divided by time, and again we can use a formula triangle for that. So speed, distance and time. This one says Riley travelled by car and by aeroplane. He travelled 143 miles by car, and it gives us the speed. He then travelled for 5 hours and 20 minutes by aeroplane. Work out in hours and minutes Riley's total time travelling, or total travelling time. So here, well, we already have his travelling time for the second journey, 5 hours and 20 minutes. We just don't have the time for that first part, but we are told the distance and we are told the speed. So we can work out time. If we cover up the time on our formula triangle, this distance divided by speed, we just need to watch out, make sure we get this all in the right units. So we've got miles and miles per hour. They're in the same units. So the distance of 143, we can divide by the speed of 55. And if we do 143 divided by 55, it gives us a fraction, 13 over 5, or 2.6. Watch out for recurring decimals here. This one doesn't have a recurring decimal, but if it does, of course, we just want to multiply this by 60 to turn it into minutes. Or we can just take the decimal, so I can do 0.6 times 60. Again, this is where you have to be careful if there is a recurring decimal, that you don't miss that. But 60 times 0.6 is 36 minutes. So that's 2 hours and 36 minutes. Now, of course, this was looking at the total travelling time. So we also have the 5 hours and 20 minutes. Now, as it turns out, this gives us a nice amount of minutes because the 36 and the 20 is not going to go over the 60 minutes. So when we add these together, we get 7 hours, and 30 and 26 makes 50, so 56 minutes. So obviously just be careful there. If that does go over the 60, that will of course turn into an additional hour, and you'll have some extra minutes left over. But this one didn't, so 7 hours and 56 minutes for our total travelling time. Now, there are lots of different methods to use for compound interest. This particular one here, I'm going to use a multiplier, but you can use other variations and even different methods of using the multiplier. So we've got £25,000 for 3 years in a bank. We have the personal bank, which offers 2% compound interest each year, and then secure bank, where the interest changes from 4.3% to 0.9% after that first year. We want to know which bank gives the most interest after 3 years. Well, if we go for the compound interest for the personal bank, we have £25,000, and the multiplier for 2% is 1.02. Now, typically with compound interest, it's always 1.0 something, but if you're not sure, you can add the 2% to 100, which is of course 102, and then you just divide your answer by 100, and that comes out as 1.02. You may recognise them. Of course, there is another way you could do it. You can actually just type in 102 and use a percentage button on your calculator, which if you've not seen, try and find that. It's normally behind the answer button, and you press equals, and you get 1.02, and it gives you the multiplier for you. So 1.02, and we want to put a power of 3 for 3 years. So 25,000 times 1.02 to the power of 3, and that comes out as a total amount of £26,530.20. For the other bank, we have 2 different percentages. So we'll have 25,000. This time we'll times by 1.0, and it'll be 43 for 4.3%. And again, you can use either of the methods in the top right there to find that multiplier. And that's only for the first year. So I could work that out and then deal with the next one. But as I'm going to go straight onto the next one anyway, I can just times by the next multiplier, which will be 1.0. And this is a weird one because it is less than 1%. It's actually now going to be 0.9. So it's quite a small number there in terms of the multiplier, and that's going to be for 2 years, so a power of 2. Again, I just want to type that in. I've already got the old one typed in, but that has a power of 3, so I'm going to have to get rid of that. 1.043 times 1.009 squared, because we're getting that for 2 years, and that comes out as £26,546.46. Now this one does say which bank gives the most interest, so I don't necessarily have to calculate the exact interest there because they have the same amount going into both. I don't need to, I can just have a look at which number's the biggest. So this one here, Secure Bank, we've got £16.26 more, so we would say Secure Bank as our answer here, and we've got all the working to show that. Just watch out, if it does obviously give different amounts, you would need to subtract the 25,000 from those amounts and actually say the exact amount of interest for each one in order to make that comparison. But as this one had the same starting amount, we could just have a look at the biggest number. And there we go, that was some compound interest. Now, pressure, force and area is nice in the sense that you are given the formula. Now, typically you'll be given either a diagram or, like this one, you've got no diagram. One of the common questions which is coming up is actually asking you to find out the area of the base of a shape. This one here says it's a box in the shape of a cuboid. You can always draw a picture for that. It doesn't need to be an amazing diagram, but a cuboid's relatively nice and easy to draw. It says the box exerts a force of 180. Now if you're going to write it into the formula, that means on the top here we've got the 180, and there's a pressure of 187.5. The facing contact with the floor is a rectangle and it has a length 1.2 and a width of x. So here, as we mentioned, there is a missing area. Now you can write the formula into a formula triangle like we did with speed and density. Pressure, force and area. Now if you want to work out the area, cover up the A, and it's force divided by pressure. So the force is 180, the pressure is 187.5. So we can type that into our calculator. That's going to give us the area, 187.5 on the bottom. It gives us a total area here of 0.96. Now the units are in metre squared, so that's metre squared. You don't necessarily need the units at this point. We just need to know that that is the area of the base of this shape. So 0.96, and the width is, or the length is 1.2. Now that means it's 1.2 multiplied by the width, which is equal to 0.96. Of course, you could just write that as 1.2x. Now to solve that, we would just need to divide by 1.2, and we would have our length of x, which is 0.96 divided by 1.2, and that comes out as 0.8. So there we go, the value of x is 0.8, that's the width of the rectangular base. Now for a vector diagram, typically this one here, it could give us the vectors, this one hasn't, we have to find them ourselves. So from here, we look from the start to the end of the line, that goes 1 across and 2 up. So A is the vector 1, 2, and B, here's the start, here's the end, it goes 1 across, 3 down. So B has the vector 1, negative 3. And this particular question says, on the grid, draw and label the vector A plus 2B. So to work out A plus 2B, we would take A, 1 and 2, and add to that 2 lots of B. So if we times this one by 2, it's 2 and minus 6. And then we just add those top numbers and those bottom numbers. 1 plus 2 is 3. 2 add negative 6 is negative 4. As we are adding a negative, we just take away 6. And we just need to find a place where we can draw this. That means 3 to the right and 4 down. So I want to go somewhere where I can at least go 3 to the right. So maybe I could fit this in here. If I go 1, 2, 3 to the right, and then 1, 2, 3, 4 down, I end up just there. I want to join that up from the start to the finish, drawing a little arrow to show the direction that goes. You can label it if you want. I could label that A plus 2B, and there we go. There is my vector diagram drawn. Okay, so sharing in a ratio. We've met lots of different questions with ratio. I'm sure you've seen lots of ratio questions. All of them have their own little unique sort of style to them. This one here is very unique. It says Carlo puts tins into small and large boxes. He puts 6 tins into each small box, 20 tins into each large box, and Carlo puts a total of 3,000 tins into boxes, so that the number of tins in small boxes to the number of tins in large boxes is 2 to 3. It then wants us to have a look at the percentage that are large boxes, and we can deal with that in a moment. But here we have 3,000 tins, and this is the ratio it tells us that they're going in. So regardless of what the question's asking us about, we want to split this into the ratio. So 3,000 divided by 5, again we can do this on the calculator, is 600, and then we can share that straight in the ratio 2 to 3, timesing each by 600, and that gives us 1,200 and 1,800. Now that is the number of tins in small boxes to the number of tins in large boxes. Now it says here the 6 tins go into each small box and 20 tins go into each large box. So this is the tins. We can now work out how many boxes there are for each one. So we had on the left small, on the right large. There are 6 tins in each small box, so we can divide this one by 6. And there are 20 tins in each large box, so we can divide this by 20, and that'll tell us how many boxes there are. So 1,200 divided by 6 is 200 boxes, and 1,800 divided by 20 is 90. So overall there are 290 boxes. It says Carlo says that 30% of the boxes filled with tins are large boxes. Well, here's the large boxes, there are 90 of them, but is that 30% of all the boxes? Well, to work out a percentage of an amount, we can do 90 out of the total amount of boxes. The total amount of boxes here is 290, so 90 out of 290. We're going to type that in on the calculator. 90 over 290, it does come out as a decimal, so we want to times that by 100, and that'll turn it into a percentage. This one here does have a few decimal places, but it comes out as 31.04 and a few extra decimal places percent. So it says here, Carlo says that less than 30% are filled with large boxes, but we've just shown that actually 31% are filled. So is Carlo correct? No, Carlo is not correct. There we go, and that's backed up by nice clear working, and there is our final answer. So that was looking at some ratios, but it also involved a bit of percentages, so you just got to watch out for these questions. But the really important part here is be super happy with all those different forms of sharing in a ratio, and again I'll link that in the description for all those different types of ratio questions. Okay, so looking at a percentage change, it says here, Nimra buys a 3 kilogram box of sweets for £17.60. She puts the sweets into bags to sell, and each bag contains 150 grams. So straight away we can work out from this exactly how many bags she's going to sell. 3 kilograms is 3,000 grams, and we want to divide that by 150. So 3,000 divided by 150 comes out as 20 bags. So she's going to sell 20 bags of sweets. It says here she wants to sell each bag for the same price. Great. She wants to make a profit of at least 35%. What's the lowest price she should charge for each bag? Well, we want to work out this 35% profit. We can treat it almost as a multiplier, or we could use a non-calculator method, work out 35% and add it on. So for £17.60, I think the easiest way is just to use a multiplier like we do with compound interest, except we're just going to use a 1 multiplier. So 1.35 for 35%, £17.60 times 1.35, that tells us that she needs to sell all of these sweets for £23.76. That's to make at least 35% profit. Now she's going to sell all the bags for the same price, and she's got 20 bags, so if we divide that by 20, we've got the amount that she's going to have to sell it for. Now that comes out as, and let's just type it in, £23.76 divided by 20. It comes out as £1.18 and an 8 afterwards. Now that means, because the little 8's there, if we only sold these bags for £1.18, and you can work backwards, £1.18 times 20, she would only get £23.60. So she wouldn't have the 35% profit, she'd have close to it, but it'd be just under. So we are going to have to round this up. She's going to have to sell them for £1.19, which is the smallest amount that she can actually sell them for, and £1.19 times 20 would give her £23.80, and she'll make that 35% profit, just over, but she makes at least 35%. So there we go, £1.19, and that was looking at a percentage change there. Okay, so from this point onwards, we'll be looking at the higher only content. So if you are sitting the foundation exam, the rest of the topics from this point will not be relevant to you. So hope you enjoyed the video, and hopefully I'll see you for the next one, where we look at our practice paper the night before the exam. If you are sitting the higher paper, great, stick with me and we'll carry on. Okay, so in this question we're having a look at some reverse percentages, and this is about depreciation. So it says here, at the end of the first year, a car had decreased by 12.5%, and then it decreased by 10% each year for the next 2 years. And at the end of those 3 years, it was £17,010. We want to know the value of it 3 years ago. Now with depreciation, our multiplier, if we imagine this as a bit of a timeline, we have the start, year 1, year 2, year 3. Now each time this has been multiplied by something which is decreasing it in value. Now between year 1 and 2 and 2 and 3, that's quite a nice easy one. That's just multiplying by 0.9, which is 90% when you remove the 10%. The other one we'd probably want to use our calculator for, 100 take away 12.5 is 87.5%. So that is being multiplied by 0.875. So that's what we would do to reduce by 12.5% and then further reduce by 10%. We could write the 0.9 as 0.9 squared, as it's going down by the same amount for those 2 years. Now essentially at the end of the 3 years there, it's worth £17,010. So to go back in time, we would just do the inverse of these, which would just be dividing by 0.9, then dividing by 0.9 again, or of course you could write divide by 0.9 squared, and dividing by 0.875. So if we just do that in our calculator, and we can just do it in single steps, we don't have to include the powers and sort of add those additional bits in. When we divide by 0.9, it becomes, and I'm going to write down each one as we go, 18,900, then divide by 0.9 again, and we get to 21,000, and then divide by 0.875, and we get to £24,000. And there we go, that is a reverse percentage, where we were looking at something which had been depreciated and has now reversed back in time, back to that original value. So looking at some negative and fractional indices, which is a topic which tends to appear more on a non-calculator exam. However, there are these variations that you can't type into a calculator. So here we have, in our first example on the left, we have the problem where we're looking at similar base numbers. Now here, these are all powers of 2. 16 can be written as 2 to the power of 4, and 8 can be written as 2 to the power of 3. So this type of question is all about rewriting the base numbers to the base sort of power that we're looking at, and here we're looking at powers of 2. So that's 2 to the power of 4 to the power of a fifth, times 2 to the power of x, which is already a base of 2, and then we have 2 cubed, which is to the power of 3/4. Now powers in brackets just get multiplied, so 4 times 1/5 is 4/5. The 2 is just to the power of x, and 3 times 3/4 is 9/4, so 2 to the power of 9/4. So although the powers look more complex, we can just apply our normal laws of indices. So adding the powers of 2 when we're multiplying, we'd have 4/5 plus x, and that's equal to 2 to the power of 9/4. So now we actually just have to compare the powers. 4/5 plus x has to equal 9/4. So to solve this for x, we would do 9/4 and subtract 4/5. Now thankfully, that little step there we can actually type into a calculator. So 9/4 take away 4/5, and that equals 29/20. or as a decimal, 1.45. So I'll write the answer as a decimal there, just it's easier for me to write, but there we go, either answer there would be fine, 1.45. Now the second question is a reverse power sort of rule here, where we are looking again at powers in brackets, but we also have a fractional power. Now we're looking here to see what's changed because there are missing pieces. It wants us to find the value of a and the value of n. Now the easiest bit for us to spot here was, well, the bit that doesn't work, a to get to 7, we don't know because we don't know what root has been done here because of the missing n. So we've got 2 unknowns in that one, so that one's going to be a little bit more complicated to find. But if we look at the 3, and here it started with a 6, you can see there that the power has halved. And therefore the power in place of the 1 over n has to be 1 over 2. It has to have halved the power. And we know we multiply powers in brackets, 6 times a half is equal to 3. So we know just by looking at that n is equal to 2. Now that allows us, so I guess we could rewrite it, just to make it a little clearer, that is now to the power of a half, and it equals 7x to the power of 3. Now we can look at the a and how we get to the 7, because a power of a half does a square root. So here it's basically saying what number has been square rooted to get the answer 7. Well, 7 squared is 49, so 49 must be the value of a, and we can always write this. And if we work that out, we would do the square root of 49, which is 7. We'd have the x and the power there, 6 over 2 is 3, so we get 7x to the power of 3. So there we go, we get a is equal to 49 and n is equal to 2. Okay, so a cumulative frequency graph we plot on the endpoints. So when looking at your cumulative frequency table, just make sure whether this language is here, cumulative frequency, or it says frequency. If it says frequency, you're going to have to add them up as you go down, getting those cumulative totals. This one's been done for us, so we definitely don't want to add those up, otherwise it'll end up going off the graph, but we're going to plot on the endpoints, again being really careful with the scale here, onto 60, onto 25, 80, up to 35, 38 for our next one on 100, and then our final one landing on the 40. Now, do have a look at this starting number here. Don't assume that the cumulative frequency curve joins up to the origin. It doesn't. It starts at that first time, which is down here at 20. It's almost worth marking that number first. And then we join this up with a nice smooth curve going through all those points. And that's your cumulative frequency curve. You'll be asked lots of different questions on this. You can look at the median, the interquartile range, which we're going to have a look at here, or you can have a look to find certain values at certain times. Just read the question carefully. Here, the median, we would go along from 20, as that's half of 40, the total, and we would go across and read down. The interquartile ranges, we're going to find the halfway point in this first half and the halfway point in this second half here. Now that is going to be from 10, so we go across from 10, we go down, we read the value exactly as we get it. This one here for me with 50 in the middle there looks like, because that's going to be every 2, that's going to be 45 for my reading. And then if I go across from 30, which is halfway along in that upper quarter there, I try and draw my line down as straight as I can. That for me comes out as 62, 4, 6, 7, maybe 68 there. It's just going into, and you will have a range of values that you're allowed to work out here. For the interquartile range, I need to do the bigger take away the smaller. So 68 take away 45. And again, just little scenarios like this. I know that's an easy subtraction to do, but just make sure you use your calculator. And there we go, 23 for our interquartile range. Now, a box plot can be nice, it can be not so nice, depending on what values you're given. This particular one is a relatively nice one because all of the values that are given to us here are ones that we can plot straight away. So here, 169, and you can see why, hopefully, on this one we are given nice values because the scale isn't particularly nice here. Now, looking at one part of the scale, here there are 10 squares between 155 and 160, which means every square is 0.5. If you take the gap, 5, and divide it by the amount of squares, you'll know how many there are per square. So here it's 0.5. So 169 will be 2 squares before the 170. That's our least value, or our least height. The greatest height is 186, 2 squares after the 185. Sort of tick them off as you go, and then the median is 177. So that's going to be 4 squares after the 175. It does get a bit awkward with this scale. 174 for the lower quartile, 2 squares before 175. And then the upper quartile on 180. Thankfully that's a nice whole number there. And then we can join this up and draw our box plot. And there we go, that's drawing a box plot. Don't forget, you can be given different values in here rather than just telling you them between the least and the greatest. That's called the range, which you could be given as well, so you might have to find the least or greatest. And between the lower and upper quartile, you could be given the interquartile range, which allows you to move between the two as well. But we've plotted all 5 of them, and we're also asked to make a comparison. Now the comparison here, it says compare the distribution. Now when we're looking at distribution here, we are going to look at the median and we are going to look at the interquartile range. The interquartile range is the box in the middle, and it tells us how spread out the data is because that includes half of all the people that are within the box plot. You've got the upper quartile on the right of it, and you've then got the lower quartile on the left of it. But we've got half the data inside that box, so that tells us how spread out the data is. So when we're looking at this, first we'll compare the median. You can see the first box plot, the median is higher. It's gone past 175, it's on 177. Not that we need to say any numbers, in fact it's probably better that you don't, because if you get the number wrong, you get the comparison wrong. So let's just say whether one is bigger or smaller. So first point here, and I'm not going to write them down, I would say that the median for the adults is greater than the median for the teenagers. However, we need to include the context of the question. Here, it's about height. So the median height for the adults is greater than the median height for the teenagers. So that's one comparison. Our second comparison, we are looking at the box there, the interquartile range. Now, in order to make that comparison, sometimes you can see which is bigger. If you can't, then I would advise checking the numbers just to make sure. So that goes a distance of 6, it goes from 165 to 171. Over here, and we've got the numbers for this in our table, it goes from 174 to 180, and that has an interquartile range of 6 as well. So this one is quite a unique one. The interquartile ranges are the same. So here we would say they have the same interquartile range, which shows that the heights are equally spread out. There we go. Of course, if one was bigger, you could say one was more spread out or less spread out, just depending on the context, of course, depending what the question is actually talking about. And there we go. That is looking at a box plot. Okay, so expanding 3 brackets is all about just keeping this very tidy. We're going to pick 2 brackets to start with. It doesn't actually matter which 2, but I do always just tend to pick the first 2, as I tend to find that expanding a double bracket is relatively nice. So we just want to make sure we get all of these correct. So that's going to be 6x squared, and then plus 3x, plus 4x, and then plus 2. And just double check, you don't want to get any of these pieces wrong because it's a lot of work, it gets quite messy, you definitely don't want to have to backtrack. So do double check those. 3 add 4 is 7, and then plus 2. Now we want to expand or multiply this expression by that final and third bracket. So we'll put this into a bracket, introduce that third bracket, and we want to have enough space for this because it does get a little bit messy, so it can help just to make sure you've got enough space down below that so you can actually draw in your lines or any other method that you use. So starting with the 6x squared, we'll times both of those. That gets us 6x cubed minus 30x squared. Then onto the 7x multiplied by both of those. So plus 7x squared minus 35x. And then finishing off with the 2, there's not really any more places to draw any connecting lines, so I'm just going to draw them through the middle here. So plus 2x minus 10. So we just need to simplify that. So tidying any of the like terms, you've got 2 here and 2 here. So we've got 6x cubed minus 30, add 7, and again, just little things like that. You can type that on your calculator, minus 30, add 7. I know it's not difficult, but in the heat of the moment, when you're practicing and you're going through all of these different multiplications, just use your calculator. Make sure that it's absolutely perfect. So minus 23x squared, you've got negative 35, add 2, which is negative 33x, and then minus the 10 at the end. And there we go, that's expanding 3 brackets. So this question here is looking at the volume of cones and spheres. Thankfully, you are given the formulas for those, so they'll be next to the question. So have a look at your formulas, just make sure that you are super happy with using them, finding your pi button on the calculator, and we're just going to work out anything that we can see. So this particular one here tells us that the total volume of the shape is 120 pi, and the total height is y. So we are going to work out the value of y in this question. So here, when we're trying to find this missing height, well, we're going to have to work out the volumes. So if we go about working out one of the volumes, we can identify that we cannot work out the volume of the cone yet because we don't know the height. If we had y, then we could, but we do know the height here of the sphere or the hemisphere because it is the radius. So the radius goes from the centre of that hemisphere down to the bottom of the sphere here. So that's going to be half of the 7, so that's 3.5. So we do have part of the height already. We just need to work out that volume that's just the cone. So if we use the volume of a sphere formula, we have 4/3 pi r cubed. However, for a hemisphere, we can halve that as it's half of a sphere, and that's timesing this formula by a half. If we times it by a half, instead of being 4/3, and you can do this on your calculator, 4/3 times a half is 2/3, of course, half of 4/3. So 2/3 pi r cubed. So we can use that straight away. So 2/3 times pi times 3.5 cubed. That's going to give us the volume of the hemisphere. So we can type that in, 2/3 times pi times 3.5 cubed. That gives us a volume. It's not a particularly nice one. It comes out as 343 over 12 pi. So there we go. You could write the decimal version of that down if you wanted, but I'm going to leave it in terms of pi. So for this bit next, we're going to take that away from the total volume that's given to us, so 120 pi, minus this 343 over 12 pi, and that's going to give us the volume of the cone. So 120 pi minus the answer on the calculator, and that comes out as 1097 over 12 pi. So that right there is the volume of the cone. Our formula for the volume of a cone is right here, 1/3 pi r squared h, and all we need to do is work out the height. We have all the missing pieces, so we could set up the formula. We have 1/3, we're kind of running out of space here, let's do it down the side, 1/3 pi times 3.5 squared times the height is equal to 1097 over 12 pi. Just about fit it in there. And now to isolate the height, we can take all 3 of these pieces and divide those to the other side. So we get the height is equal to 1097 over 12 pi divided by, and then we have this 1/3 pi times 3.5 squared. Now I'd probably write that as a fraction on my calculator rather than as a division like that. Probably going to be a lot easier for us to do. So I already have the answer on my calculator, so I can put the answer over and then do 1/3 times pi times 3.5 squared. Now that gives me a final answer. It comes out as either a decimal or as a fraction. I'm going to write this one as a decimal. It comes out as 22.3877551. Okay, so that is the height of the cone, and to get the height of the overall shape, which we've got over here, we've got the 22.38, we're going to need to add the 3.5, which is the height of the hemisphere, and if we add 3.5, it comes out as 25.887, so 25.887, and we want that written to 3 significant figures, so that's going to be 25.887 0.9, and that's in centimetres, and there we go, that is our final answer, 25.9. So basically, just using your formulas, we had using the formula once, normally, for the sphere, of course only doing half of it though, as it was a hemisphere, and then we had a formula in reverse to find the height of the cone. And this one here wanted the height of the overall shape, so we've added those two together. And there we go, that's a bit of volume of cones and spheres. Okay, so for this question we're going to be looking at a circle problem, not necessarily a sector here, but a really nice little circle problem. Now it wants us to work out the circumference of a circle, and the formula for that is circumference is equal to pi times diameter, which means the problem here is working out the diameter. Now we have this rectangle inside the shape, and spotting the process for working out that diameter, I guess, is the challenging part here, because if we draw the diameter in, it creates a nice right-angled triangle. Now there are a lot of bits of maths that we can use to work out the missing side in a right-angled triangle, but if we have two of the missing lengths, then we can use Pythagoras' theorem. So a squared plus b squared is equal to c squared, where c squared is the hypotenuse. So a and b is our 8 and our 10, so 8 squared plus 10 squared, you can actually just square root that in one go, just saves you a little bit of time, and we'll get our answer for that diameter straight away. Now it comes out as 2 root 41. You can write it as a big long decimal if you want. It has 8 decimal places. I think it's easier just to leave that as a surd. So 2 root 41 is our diameter. Now that just makes it nice and simple then to work out the circumference, because the circumference will be pi multiplied the diameter, which is 2 root 41. So we can just times that by pi, and we've got our answer. It comes out as 40.23201,613. And there we go, there is the circumference of the circle. It does ask us here to give it to 3 significant figures. So if we chop it after that third significant figure, it comes out as 40.2 centimetres. And there we go, there is our final answer. There we go, we'll put the units for that as well. Okay, so for circle theorems, there are so many different types of questions that you could see. This one here involves a nice little selection of some different circle theorems. It asks us to work out the size of angles CDE. CDE is this angle here, and we have one other angle within the triangle. We've got the 16 down outside of the circle there. So this circle theorem, again, and knowing your circle theorems and just being able to spot here that that's an angle at the circumference, and here we have an angle at the centre, which means I can divide this angle by 2 and work my way up to that angle A. So 132 divided by 2 is equal to 66. It does say give a reason for each stage here. So for that one, I would write that angles at the centre are half angles at the circumference. From there, we can actually see that there is a cyclic quadrilateral. So a large quadrilateral here where all 4 points are touching the circumference of the circle, meaning that the opposite angles add up to 180. So I can do 180, take away 66, which means this is 114. Again, I would write next to that because opposite angles in a cyclic quadrilateral add up to 180. So I've got a few of these angles now. I've given 2 reasons. I just need to think about, is there another circle theorem, or can I start to get into my answer? Now I have a straight line, BCE, which means that next to the 114, these two add up to 180, so this would be 66. I now have 2 out of my 3 missing angles in this triangle on the outside. We can get our final answer doing 180 take away the total of 66 add 16. I can type that in one go. 66 add 16, take that away from 180, we get 98 degrees. I could give 2 more reasons in those final steps there as well. We had the 66 because angles on a straight line equal 180, and 98 because angle in the triangle adds up to 180. So we had 2 circle theorems and 2 just angle rules that we gave along with that as well. But there we go, there is one variation of a circle theorem. Of course, there are absolutely loads of different styles of questions, so I will link the video for circle theorems in the description. You can have a look at some different examples as well. Okay, and looking at a quadratic sequence. For this particular quadratic sequence, I am going to use the formula for working it out, but regardless of which method you use, we need to find that second difference. So from 10 to 21 is 11, and 21 to 38, that is a difference of 17. That looks like it's going up in sixes, but let's just double check. 61 to 38 is a difference of 23. So there we go. These are, in fact, going up by 6 as our second difference. Now, the second difference is always divided by 2. So just as a failsafe, write down 3n squared, as that is 6 divided by 2. Now, that's going to get you a mark. Now, I'm going to use formulas for the 3 pieces in my nth term. So 2a is equal to 6. 3a plus b is equal to 11, and a plus b plus c is equal to 10. I just need to solve these, and then they all go in place into my quadratic nth term, which is written in the form an squared plus bn plus c. So if we solve these, we've already got a is equal to 3. I can then move my way up. So if a is 3, this is 9 plus b is equal to 11. So therefore b is equal to 2, so plus 2n. And then we know a and b, so we have 3 plus 2 plus c is equal to 10. That's 5 plus c, so c has to equal 5. So that's plus 5 at the end, as it was at positive 5. So our final answer is 3n squared plus 2n plus 5. And there we go, there was the nth term of a quadratic sequence. Okay, so in this question we're having a look at some bounds, and this one here is in the context of speed, distance and time. So it wants us to work out a speed, and it says by considering bounds work it out. So first of all, we want to make sure that we know our speed formula. So speed is equal to distance over time. Now for this one we have some quite awkward numbers. It says the distance is 10.6, correct to the nearest 0.1. So for the distance, which is between these two values, we have 10.55 and 10.65, going that 0.05 above and below. The time is very awkward because it's written in 31 minutes and 48 seconds. Now if we convert this just into seconds so that we have a number that we can actually write a bound for, well 31 times 60 is 1860. So 1860 plus the 48. So plus 48, that gives us 1908 seconds. Now the speed is in kilometres per hour, but that doesn't mean we can't work out a speed in kilometres per second and then just change it into hours. Of course, we just times it by 60 for kilometres per minute and times it by 60 again for kilometres per hour. So if we write our error interval for the time, let's call that t, and that'll be between the 1908.5 and 1907.5. Now, as we are considering bounds, it means that we have to work out the upper and the lower bound. So to get the upper bound, which is the biggest possible answer for speed, we're going to do the biggest distance divided by the smallest time. So 10.65 divided by 1907.5. And for the lower bound, we're going to do the smallest distance, and we'll divide that by the biggest time. So 10.55 over 1908.5. Now when we do this, that is going to give us a speed in kilometres per second. So if we were to times both of them by 60, that's going to turn them into kilometres per minute. And to turn that into hours, we're going to need to times it by 60 again. So rather than writing down loads of numbers here, I'm just going to do it all in one go. So 10.65 on the numerator, 1907.5 on the denominator, times 60, and that comes out as 20.09960682. We need to do the same for the other one. I'm just going to swap the 7 on the bottom for an 8, and on the top the 6 for a 5. And there we go, that comes out as 19.90044538. So these are our two bounds, our upper bound and our lower bound. And by considering bounds, we have to decide on how we are going to round this so that they both round to the same number. So always start as accurate as we can. I can see if I go, for example, to 2 decimal places, they're not going to round the same. Our first one there would round to 20.0 and the 9's going to round up, so 20.1, and the bottom one would round to 19.9. So I'm going to have to go less accurate than that and see if it works. 1 decimal place will be 20.1 or 19.9, so that doesn't work. So we'll go to 2 significant figures, and that rounds to 20, and this one rounds to 20. So there we go, that would be 20, and I would give a reason somewhere because they both round to 2 significant figures the same. I'll put here same to 2 SF. And there we go, that's looking at bounds, and that also involves some compound measures, specifically looking at speed, distance, time here. Okay, so these questions where we have sine and cosine in the same question are always quite lengthy, but we just need to work around the shape. Now here it says to work out the length of QS. QS is this side over here. Now typically it would be a little strange to put 2 triangles together if we didn't need to use the other triangle at all. So here the problem is we have an angle opposite that side, but the other angle that we've been given, we don't have the opposite side. And we don't have the side opposite this angle here. Of course we could work out that missing angle because of angles in a triangle, but we don't have the opposite anyway. So if we move into the other triangle, well, this side is opposite the 27, and again we don't have any other side, but we do have these 2 adjacent sides to the angle, which does indicate that we can use the cosine rule. So here this side would be my A and my big A, and these would be B and C. The cosine rule is given to you, and we just need to plug in the values. So A squared is equal to B squared plus C squared minus 2 times B times C times cos big A, and that's going to be 27. Now you can get away with square rooting the whole thing and just doing it all underneath the square root. That's going to avoid you just accidentally forgetting to square root your answer. Hopefully you would notice that the answer would be way too big before square rooting it. And there we go, type it all in and we get a final answer for A. A comes out as 5.009975129. Now over on the diagram, I'm just going to write 5.009. I could probably put a few of these in, 99. There we go. I'm going to put a few dots after it, just so I remember that's not the full value there, because although it wants me to round my answer to 3 significant figures, I'm not going to do that to the very last step. I can move on to this second triangle now. Now I can use the sine rule. I can do A over sine A, so as that's already A, let's call this big A, and then equals B over sine B. So if I plug the values in, we have 5.009, this number, over sine 41, and that's equal to the one we're looking for, B over sine 88. To isolate the B, we times both sides by sine 88. And if I want to write that out in full, it would be 5.009 sine 88 over sine 41, and that is equal to B. So I can type that in. When I type it in, I'm going to use my answer button. So answer sine 88 over sine 41. And that's going to use that full unrounded decimal for me. And that comes out as, for B, 7.63181. And to 3 significant figures, after the 3 there, that'll be 7.63. There we go. This is in centimetres, so 7.63 centimetres. And there we go. That was using the sine and the cosine rule together in the same question. Now, iterations are a relatively nice topic. We've got iterations not in context and in context, which we're going to have a look at. For part A here, it says show that there's a solution between 0 and 1. Really nice question. We just substitute 0 into the equation to start with. So 0 cubed plus 7 lots of 0 minus 5. That on your calculator equals -5. And then 1 cubed plus 7 times 1, take away 5. Again, we'd want to type that in, but that comes out as 8 take away 5, which is 3. And then here you can see that the 0 that we're looking for is between -5 and 3. And therefore, there must be a solution between 0 and 1. Part B here is asking us to rearrange this to show that it can be given in this form. So we have our equation. You can see, however, here the highest power of x is 3, and here the highest power of x is 2. The only way that can happen is if some factorisation has taken place and the 5 has become positive, and here it was negative. So if we take the approach of first moving the 5 so that it becomes positive, and seeing what we have left equals 5. I've got to show this, so I'm going to put plus 5 on here. If I now factorise x out, we drop the cubed down to a squared, and we get the 7. And you can see now as well, the plus 7 over here matches this plus 7 over here along with the x squared. So to isolate the x, we would divide by the bracket, and it's basically just writing what it's asked us to show as this final step here. So x squared plus 7 on the bottom. You could write here divide by x squared plus 7, of course, just to make sure that we show that nice and clearly. The final part here is using this as an iterative formula. So it says to start with the number 1. So here is our formula here. It says to find the next number. We do 5 over the current number squared plus 7, and it wants us to do it 3 times. So we're going to find x1, x2, and when we find x3, we will be done. Now, finding x1, we're going to do 5 over 1 squared plus 7. Now that gives us 5 over 8, or you could write that as a decimal, 0.625. Now we're going to put 0.625 back in. So on my calculator, I'm just going to go back, delete the 1, and put the answer button there. And that subs it in for me. This one does give me quite a long decimal. Now, when I'm writing the working out down, I'm just going to write some of the decimal places. So I'm only going to write a few. There we go. I could even write less than that because all I have to do is press equals again. And now it gives me a solution. It comes out as 0.6704483,001. It's not asked me to round it, so in this case I'm going to write the full decimal out. If the full answer comes out as some sort of strange recurring looking number, it is okay just to write it to a certain amount of decimal places, but just make sure that you write lots down so it's really clear that you've understood the question and written down as many values as possible. But there we go, there was an iteration without any context, just finding estimations to the solutions of an equation. This question is actually looking at an iteration in context, and we've got this concept of there being an unknown constant in the question. Now this one is actually about profit, so it says the profit made by a shop is given by this formula, AP plus 800. That means A times the current number plus 800. It says in 2018 they had 24,000 profit, and in 2019 they had 29,600 profit. Work out the profit predicted to be made by the shop in 2021. So obviously the next year would be 2020, and then we're looking for 2021. Now we're going to use these two values because this is the next number from the first year, and this was the current number in the first year. And if we put those pieces in place in our formula, we get the answer, which is 29,600, was equal to A times the current number, 24,000, add 800. Now let's get rid of the 800 and see what the current number times A would have equaled. So minus the 800, and let's just do that on a calculator, even though it's not too bad. It just dropped down by 200 underneath the 29,000, but 28,800 is equal to A times 24,000. So we can get the value of A here now by dividing by 24,000, and that's going to give us A is equal to, divide by 24,000, we get 6 over 5, or 1.2. 1.2 is a multiplier which increases by 20%. You can test it out. 24,000 times 1.2 gives us the 28,800. Then add 800 like we have in our formula and we get 29,600. So there we go, it matches, it works. So for the next one, we're going to now times by 1.2 and then add 800 and we get 36,320. And then we're going to times by 1.2 and add 800 and we get 44,384. And there we go, there is our final answer for that value there in that 2021 year. So 44,384, and that's in pounds. And there we go, there was some iterations in context and with an unknown constant. Okay, so looking at the product rule for counting, and we've got quite a unique question here. It says, at a sports camp, there are 32 senior players and 32 junior players. 18 of the senior players are left-handed, 11 of the junior players are left-handed. A senior and a junior player are going to be chosen to form a training pair, and Liam thinks that both players will be right-handed in more than 30% of the possible pairs. And is Liam correct? Well, the total amount of pairs that can be chosen between a senior and a junior player is 32 times 32. So 32 times 32 gives the overall amount of possible pairs, which is 1,024. Now, here we are told about the left-handed players. If we were to do 18 times 11, that would tell us the total amount of left-handed player options. But we want to know about the right-handed players. So we can do 32, take away 18 for the senior players to see how many are right-handed, and that is equal to 14. And 32 take away 11. 32 take away 11 is 21, and these are how many right-handed players there are. So if we do 14 times 21, that tells us the total amount of pairs of right-handed players that can be chosen, and that's 294. Now we want to work this out as a percentage. Now there are two ways of answering this. We could work out 30% of 1,024. That's one option. So we could do 1,024 times 0.3, which will work out 30%. Now that gives us an answer of 307.2, and that would be 30%. Now we have already worked out that only 294 of the options are going to be or possible right-handed pairs, whereas 30% is 307.2. So Liam is wrong because there is only less than 30%. The other way that we could do this is we could do 294 out of 1,024, which will work out the decimal version of our percentage, and then of course times that by 100, and if we times that by 100 we get 28.7%. So either way we can see that that is less than 30%. So here we would say Liam is not correct. And there we go, all centred there around the product rule for counting, but quite a tricky variation that also involved looking at the percentage of a set of options. Okay, so for completing the square, I think a relatively nice topic, we just take this number here in the middle, the coefficient of x, and we halve that and put it into our squared bracket. Keeping the symbol that's with that, so it'd be x minus 3 squared. Now we can either expand that double bracket, or what we actually need is just to think about what number we would get at the end. Negative 3 times negative 3 would give us positive 9, and we just compare that to the expression in the question. This expression wants a plus 1, we would have a plus 9, so we're going to have to subtract 8. So the value of a there is the 3, so a equals 3. Paying attention to the symbol here, it does say minus a, and we've got minus 3, so a is 3. And b is equal to 8, again paying attention to the symbol, it says minus b, and we've got minus 8, so the b itself is just the number 8. So there we go, it does also say here, write down the coordinates of the turning point of the graph, and our turning point is within the brackets for the x-coordinate, which is the 3 here, but we flip the symbol, so positive 3, and the y-coordinate is this number at the end, negative 8. We only flip the symbol for numbers in the brackets there, so our coordinate is 3 and negative 8. Now an inverse function is relatively nice if your function doesn't look particularly nice, or if it's got something like this where we have a bracket that we just need to sort out first. We can expand that, so it gives us 6x plus 3. Now this wants us to find the inverse function of g, and it wants us to substitute 6 in. There are different ways of doing this, but I prefer just to find the inverse. So I write it as y is equal to 6x plus 3, and then make x the subject. So take away 3 from both sides, we get y minus 3 is equal to 6x, and then divide by 6, which gives us the value of 1x. We get y minus 3 over 6 is equal to x. We then just write that as an inverse function, so g minus 1 of x is just equal to x minus 3 over 6. Now we're being asked to substitute 6 into that, so now I can substitute the 6 in. 6 minus 3 divided by 6. I can type that into my calculator, which is 6 minus 3, which is just 3, divided by 6, and that equals 1/2 or 0.5. I'll write it as 0.5, as that's what my calculator is displaying, but you could write that as a half as well. Absolutely fine, but there we go, that was an inverse function and substituting into it. Now for a perpendicular line, we just need to know two things. One, the equation of a line, which is in the form y equals mx plus c, and the second part is knowing about our negative reciprocal. So here we're going to look at this straight line equation. We want it in the form y equals mx plus c. To get it into that form, we'd need to divide both sides by 2, and that gives us 1y is equal to 3 divided by 2x, or 3 over 2x, minus 7 over 2. Now we've done that because we want to know the gradient of the line, because if our gradient, which I'll label as m, is 3 over 2, then our perpendicular gradient, which I'll label as MP, will be the negative reciprocal of that. So we change the sign, making it negative, and flip the fraction over, making it 2/3. From here, it's just putting all the pieces now into the place that it needs to go. So for y equals mx plus c, what the y value, which is given to us in our coordinate, is negative 5. That's equal to minus 2/3 multiplied by the x coordinate, which is 6, plus c. I just want to simplify this, which I can do on the calculator as well. So minus 2 over 3 times 6 is equal to negative 4. So we have negative 5 is equal to negative 4 plus c. And add 4 to the other side, we get negative 1 is equal to c. And now I have all the pieces. I've got the value of m, which we worked out, our gradient. I've got the value of c, which is negative 1. So my equation of the line will be y equals minus 2/3 x minus 1. Now it could ask us to write that in another form. For example, it might want us to write it without any fractions involved, in which case I'd need to times everything by 3 here, which would make it 3y equals minus 2x minus 3. But you could be asked to write it in another form. This one doesn't, it just says find the equation of the straight line that's perpendicular to L and passes through 6, negative 5, and that we have done. Now a graphical inequality is a lot quicker if you can draw your straight lines nice and quick. Here we have a nice flat line for x is less than 4. X is 4 is just here, so we would draw a line. This is going to be a dashed line as it's just an open inequality, not one that's equal to as well. So it doesn't have the extra line underneath the inequality, so we don't have the extra gaps filled in. The next one here is in a slightly different form, so I'd want to minus 2x to the other side. So it's y is greater than minus 2x plus 6. Now you can draw a table of values for this. I like to just find the y-intercept and then just follow the pattern for the gradient. So for this one, the y-intercept is 6. The pattern is negative 2 in terms of the gradient, which means 1 to the right, 2 down. And I can just follow that pattern, 1 to the right, 2 down. And I can follow that all the way up, and then I can draw my nice dashed line in that area. And there we go, there's my second line. And the last one is y is greater than 1/3 x. Now that has a y-intercept of 0, so here's my y-intercept. The pattern for the gradient is 1 across 1/3 up. If it's only going a third up for every 1 across, it's going to go 1 up for every 3 across. So if I go 3 across, 1 up, 3 across, 1 up, then I can just about get those 3 points. Now I would extend this a little bit, so I'm going to try and extend it all the way through. Of course, you can use a ruler and a pencil. You just want to join all of those together, and there we go. Now for this, we need to now label the region that satisfies these inequalities. Now to find the region, we need to pick a coordinate and test it out. But the problem is, we actually have a lot of regions here that we could potentially test. So what we need to do is have a look and see if any of them can cancel out some of the regions. The first one is quite nice. It says x has to be less than 4. Now that means everything on the right hand side of that line is no good. So we can cross this one off, and that is the same as the one just below there. So it has to be one of these ones on the left. Now, ideally, we would be inside this little shape that's sort of created at the bottom. But it's quite hard to see, but there is a coordinate in there we can just about test. It's the coordinate 3, 0. So if I label that over here, 3, 0. Now it doesn't take too long to test these. I'm going to write them out, but you could kind of do some of them in your head. Now x has got to be less than 4, so we've got 3 is less than 4 for that coordinate, so that's fine. For the next one, we have, and I'll just use the original one up here, 2 times x, which is 6, plus the y coordinate 0 has to be greater than 6. Well, it's not greater than 6, it's equal to 6, so that one doesn't work. So I need to pick a different coordinate. So let's pick this one just above, which is 3, 2. And we'll test that one out. So x has got to be less than 4, so 3 is less than 4. Yes. For the next one, 2 lots of x, 6 plus y, 2 has to be greater than 6. Well, 8 is greater than 6, so that works. And y has to be greater than a third of x. So 2 is the value of y. Is that greater than 1/3 of x? Well, a third times 3 is equal to 1. 2 is greater than 1, so that works. So this is my region here, R. That worked out quite nicely because I picked an x coordinate of 3 as well. I could do that in my head, but you might have had to do that on your calculator if you were doing a third of a number that didn't divide by 3 perfectly. But there we go, it didn't take too long. It's just testing a few numbers in the inequality and finding that region that works for all of them, or that region that satisfies all of those inequalities. So graph transformations is quite a nice topic. It's just remembering a few of those rules. Anything inside the bracket affects x and tends to do the opposite of what you'd expect, and outside the bracket affects y. So here, x plus 1 inside the bracket. Plus 1 you'd think moves right. It doesn't, it moves it left. So that goes left 1, and then the minus 3 affects y, does what we expect, so it goes down 3. So I just need to pick some nice whole number coordinates. There's a few here which we can move along, and I'm just going to move them left 1, down 3. So I'll start with that very left 1. Left 1, down 3 goes to here. The next one here, and then that one on the little dip there, left 1, down 3 goes to here. The next one, left 1, down 3, just here. And then 2 to the right of that is just there. So now I want to join it up, obviously nice and clear, particularly as we're going over the top of the axes there. I want to make sure that bit's nice and thick line. And then the last one, and there we go. So there's my graph drawn in. I've moved it left 1 and then down 3. Okay, so these subject of a formula questions, they do just take a bit of time. You can sort of, there's a few steps along the way that we can reduce the amount of time that we're going to take. I'm going to expand the bracket first. Now I need to multiply this denominator to the other side. I can write that as a single bracket, or I can just straight away multiply it by the d there. So df minus 4d is equal to 3 minus 3f. Now I'm going to move the piece that we're trying to make the subject, the f's, to the left. So I'm going to add 3f to both sides, and I'm going to add 4d over to the other side as well. So I'm skipping a few steps here just to reduce the amount of working out. So I have df and I'm adding 3f the 4D's going, so we have 3, and we're adding 4D to the right. Now all the pieces are on the same side, it just makes it really nice and quick to factorise the f out, d plus 3, which is equal to 3 plus 4d, and now dividing by the bracket to isolate the f gives us 3 plus 4d over d plus 3. Now there is another variation of the answer here because you can move the pieces with the f in to the right hand side, which will just change the symbols, but the answer will look pretty similar to that, just with different symbols. But there we go, skipping a few steps there to reduce the amount of working out. So I've done that in 4 lines, but you could probably write that in about 7 or 8 lines if you were to write every single step out. But there we go, there is changing the subject of a formula, including some factorising. Now, a quadratic inequality, some of the questions that you might have seen can be relatively complex, but the core skill is making sure that you know actually how to solve a quadratic inequality. Now this particular one here, we should just check to see if it factorises. Now if you have a calculator, you can of course use the quadratic formula, and that's going to save you a bit of time if you're not so great at factorising. However, it is quite a long process, particularly as if it does factorise, and you can factorise, it's quite quick to do, particularly with a 2 at the end like this one. So here we're trying to make 3, so I want to double the 2, keep the 1, and that makes it plus 4 minus 1, which makes our plus 3 in the middle. That gives me 2 solutions, x is equal to positive 1 over 2, and x is equal to negative 2. Now with a quadratic inequality, the best thing that we can do is draw a very quick sketch of the graph. It doesn't need to be to scale, it's just to visually see what we're looking at. We have a solution of a half and another solution over here of negative 2. Now there's 2 variations of answers that we can give. Here we're looking where the graph is above 0. 0 is ground level. So we're looking at these 2 parts of the curve that are above 0. This particular part of the curve here is where x is always going to be less than that negative 2. And this part over here is where x is always going to be greater than a half. So there's our solutions written as inequalities. We have x is less than negative 2 and x is greater than a half. If we were looking, and we're not here, but if we were looking at below the curve, we'd just write that as a joint inequality. X is between negative 2 and a half, obviously keeping that smaller number on the left, the larger number on the right. But there we go, that is solving a quadratic inequality. With paper 1 out the way, it's time to turn our attention to paper 2. So today's video covers my top 4 tips for GCSE Maths paper 2 revision. Tip 1, my paper 2 revision checklist. Using the link in the description, go to my website and download my paper 2 revision checklist to identify the topics that you need to prioritise. Then work through those specific video lessons available for free on my YouTube channel. Tip 2, my paper 2 practice booklets. Once you've worked through the YouTube lessons identified by the revision checklist, then you need to work through my paper 2 specific practice booklet to solidify your understanding of the topics in preparation for the exam. Tip 3, my paper 2 practice papers. The night before the exam, it's time to complete my paper 2 practice paper to refresh your understanding of the topics that I'm guesstimating will appear on paper 2. Tip 4, my rapid revision system. Alternatively, if paper 1 didn't go as well as you were hoping, or you just need a time-efficient solution due to the other subjects that you need to revise for, then you should sign up for my rapid revision program Upgrade, as it combines all the benefits of the previous points but turns them into a personalised revision plan for paper 2, which means that all you need to do is complete my paper 2 revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but if you sign up for 1 month now, then you'll get priority access to both my paper 2 and 3 specific revision resources. Sign up for a free trial of Upgrade today.